Hey everybody, what's up? I wanted to make a video about this algorithm that I saw. I saw it posted in a video that this was a coding question interview, and I was just intrigued by it, so I wanted to figure out, what was a good algorithm to solve it. And the question is where you have a square or a rectangle, and then inside that rectangle there's a whole bunch of squares, right? So it's a grid, and then each one of the squares inside the grid has a color assigned to it, and then the challenge is to find the largest contiguous area where it's the same color, right? You have all the same colored squares touching either on the left, right, top, or bottom. And I came up with an approach to it, uh, went through a couple of different solutions, refining it, and then I came up with this solution. Uh, And then I just, after I came up with my solution, I looked out there to see what other people came up with, if there was a better solution. And I just found that nobody had actually come up with this solution that I came up with. It seemed to be the most efficient algorithm that maybe somebody else had the same idea, but I hadn't found it anywhere. And other solutions that I had seen would come maybe close to the same time complexity, but not quite as efficient. So I'm going to demonstrate this in Excel. Right, so here's an example that I wrote up, and the colors can also be represented by numbers, so that's what I'm going to do here. It's just a little bit easier to work with in code, so let me clear this out. So the way that I wrote this algorithm is so that you only ever look back to the squares before, just like this, to the one that's above and the one that's to the left, and occasionally the one that's kitty corner. So the solution that most people come up with is where they have to look all around. They look at the one to the right, one to the top, to the left, to the bottom, and then they also do a fair bit of out of bounds checks because of that. So when you get to some square like this, you have to check that this isn't out of bounds, this isn't out of bounds, and then same deal up here. So you end up just checking out of bounds on every single thing that you're checking. But the way that I wrote this is first row, we're not doing any out of bounds checks. And from that point forward, we only have to check if the left one is out of bounds. So here's the basics of how it works. We start at the beginning, and then we just traverse through linearly. So here's an example, and I'm going to keep track of these in dictionary objects. I'm going to have this like each one of these squares that you see here will be a dictionary. So I'm going to have a list of dictionaries, but we go to the first one and we see that the value is 0, and then we look here to see is this color group in the dictionary, right? Because we need to have a group for this color and then a group for this color in case we encounter the same color twice. And then these white ones, these would be 3 different groups because they're not connected at the top, left, right, or bottom. So we go to this first one and we say that we don't have a red in the dictionary or a 0, so we're going to create that entry here. And then we don't have any color group for that, so we'll just assign an auto incrementing number. This will be our color group, and I'll just write this in here so it's a little easier to follow. And then we'll get the values in the next cell. So this would be 0, 0. We have the row 0, column 0. So this is a dictionary, and this is a hash table that will contain all the values. Okay, so we'll get a very fast lookup time. We go to the next one and we say, is the one to the left the same color? And it is. So we go back here into our object and we say that that color already exists and it's part of the same color group because we check to see what group is this in. And so we just say, does this hash table contain 0, 0? Does it contain the cell at that index, this row and this column? And it does. They're connected, so we're going to add it to that same group. row 0, column 1. Go to the next one, and we're just looking to the left. We say that this is not the same color, and this color doesn't exist, so we add it into this dictionary, create a new color group, because there is no existing color group for it yet, and then we add this in here, row 0, column 2. Okay, and then the next one, this is a different color compared to the previous one. And then we say, does this color already exist? And yes, this dictionary does have the color, and it already has the color group. We say that we're not connected to any previous color group. It's different from the one before. So that means that we need to create a new group for this. So I'll leave a little space for myself, just an auto incrementing number, and we're creating a new hash table here, and then we'll add in 0, 3. Okay, now that we get to the second row, from here forward, we're going to look at the one that is above and to the left. So we look at this one, and we say it's the same color, it's connected to that one, and then we have to find what color group this belongs to. Say, we look up in our dictionary, and we find that the color 0 is here, and then we're looking through these hash tables. We'll say, does this hash table contain 0, 0? It doesn't, but this hash table does contain 0, 0, so that's the group that we're going to add it to. Okay, and you might have the basic idea by now, but there's some different scenarios that come up, so I'm just going to follow this through to the end, and you can see how this works. And of course, we have to do an out of bounds checks here, so we check that that's not out of bounds. We'll do the same thing here. We'll say that this is a different color, this is a different color, it's not out of bounds, and it's a different color. So it's not connected to any squares of the same color. Look at our dictionary of dictionaries, and we find that that color already exists, and there's already a group, so we need to add a new group. So here's a new group, and we get 1, 1 in there. Okay, we go on to this one, and we say that these two are different colors, it's not connected to one of the same color, and we don't have an entry for this color, so we add it in, create a new dictionary and a new hash table, and then we're going to add in 1, 2. And by the way, I'm using for this a cell. I made a class called cell, and it just has two properties, the row and the column. So this is the object of type cell. And I've also implemented a custom hashing to make sure that the lookup always works correctly and the hashing works correctly, but I won't go into that. Okay, so the next one is here, and we see that it is connected to one of the same color. This one's different, but this one is the same color. So we're going to join to that color group. Do our lookup, find the color, and then we want the one that contains 0, 3. So we would find that immediately in this hash table, add to that group, 1, 3. Okay, next row up here, 2 rows left to go. Say that this is a different color, this is out of bounds, so we just add it to the color group yellow, or 2, but it's not connected to any of the same color, so we have to create a new hash table for that. And then this is 2, 0. Next one, we'll say that this is not connected to any of the same color. Do a lookup in our dictionary here, and we see that this color does not exist, so we're going to add it in. We create a new dictionary with this int. This is 2, 1. Okay, next one. Now these are both different colors, so we just go to here, and then we're going to add it to a new group because it's not connected to any of the same colors. Cell 2, 2. Okay, same deal here, not connected to any of the same colors, but a group already exists, so we need to add a new group. And then what's going to happen later on is all these blue colors will get connected, which is kind of the special case that comes up once in a while. 2, 3. Okay, last row. This is connected to one of the same color. This is out of bounds. So we go to 2, and then we say that we're looking for the 2, 0. And it's right here. We find it immediately. So we're going to add to that 3, 0. Okay, now we get to this one. This one is a different color. This one is the same color. So we go to 3, and we're looking for the one that has 2, 1. It's here. So we're going to add to that group 3, 1. Okay, now we get to this one. This is a different color. This is the same color. So we're just going to add it to that same group as the last one. Go to 3, and then this contains 3, 1. So we're going to add it there. 3, 2. Okay, we're at the last one, and here's this special case scenario that comes up when we're connecting the two groups. We see that these two are the same color. So what we have to do at this point is check and see that this one, is this one the same color or is it not? Because if it was just the same color, then this would already be adding, all of these would already be part of the same group, and we wouldn't need to like merge anything. But this is the special scenario that comes up when you have these two that are the same color and this one is not the same color. So in that case, what we have to do is we have to join these two lists. So we're just going to take this group, and then we have this hash table here. So we're just going to add this one to that hash table, and then we add the final one into that very same group, 3, 3. So now that we're done, we've gone through the entire grid. All we have to do is see which hash set has the most items in it. So we do a loop to loop through each one of these groups, and then we check the length of the hash set on that group. This one is 3, so that's the biggest one we've encountered so far. This one is 2, it's smaller. These are all 1, they're smaller. 1 smaller. This is smaller. And so, you know, we would say have a reference like BV, our biggest value. We put that as 3, and then when we get to the final hash set, we see that the length of this one is 5, and then we would override this biggest value to 5. So that's it. There you have your return value, and if you wanted to also return the color, then you could do that. You could have some kind of return object that has the color and also the count of how many contiguous squares were in it. So again, this is a very fast lookup, and we're only generally looking to the one above and the one to the left, which is faster than looking to every one of these squares and always doing an out-of-bounds check. We're only doing out-of-bounds checks on the left. So that's it. Hope you enjoyed the video. Maybe it helped you out a bit, or maybe you have some ideas for how this algorithm could be even improved, made more efficient. Let me know. Thanks again for watching.